Okay, Algebra 1, we are into section 9.3a. So we're kind of skipping over 9.2 right now, and we'll get back to it. And then we'll go back to it. But just after this project now, it seems good to go with 9.3a here. So transformations of quadratic equations. So we're looking at dilations, reflections, and translations. So what is a transformation? First thing is it changes the size or position of a figure. And the first one we're going to talk about is a translation. So a translation basically is going to move a figure either up, down, left, or right. So the first type we're going to talk about is a vertical translation, which, if you remember, vertical means up and down. So we're going to translate the shape up or down. So we're talking about parabolas here, so it's either going to move it up or it's going to move it down. So we're going to see things in terms of the equation f of x equals x squared plus k. Okay? So we're really focusing in on the k value here. And so in general, we can say that if the k value is greater than 0, then it's going to shift the graph up. And if the k value is less than 0, then it's going to shift the graph down. Okay, and we're talking about what does it shift from? Well, that's from the parent function of y equals x squared. So when you look at that one is this one here in blue, y equals x squared. All right, and if it's just y equals x squared, that's the parent function. Your k value is 0 there, so that's where it's at. Now the red one here shows you that the k value is greater than 0, so it shifted the graph upwards. So that's where this one came from, and then your the green one here is where k is less than 0, so it shifted the graph downward. Just a translation shifting up and down based on your k value. Okay. The next type would be a horizontal translation. So when we talk horizontal, we're speaking about left and right. Left and right. Okay. So in this case, we're dealing with the form f of x equals x minus h squared. Okay. And so this one's a little bit tricky because you kind of have to look at, in terms of opposites, okay? So when we think about this one, if h is greater than 0, it's going to shift it to the right. And then if h is less than 0, it's going to shift it to the left, okay? But something you have to factor in here is the minus sign, okay? So you kind of have to find a way to memorize this. Maybe you think it's the opposite of h or whatever you have to think, but positive h value is going to move you to the right, negative h value is going to move you to the left. So when we think about this, for example, in this red one, if we had, say, y equals x minus 3 squared, you kind of have to leave the sign. Okay, forget about the minus sign and just deal with your h value. Okay, so in this case, this would be one that shifts to the right because your minus sign leave behind, this would be your h value. And so in that case, we would say it would be like this red one here would shift to the right 3 units to the right. Okay, whereas if we did, say, one that shifted to the left, let's say it was y equals x plus 3 squared. Okay, and this is where you think, well, maybe you can think it's the opposite of h, where here you've got a negative 3, so the opposite of 3h makes you go 3 units to the right, positive. Here, it'd be a positive 3, so the opposite would be negative 3, moving 3 units to the left. Because the way you got to think about it is, in this case, the only way you can do it, since it's in x minus h squared, the only way you can get a positive 3 here is if we said it was x minus a negative 3 squared, which then, of course, 2 negatives make a positive. So that's why we have to kind of deal with that. So your h value here would technically be a negative 3. So that's why it would shift it over 3 units to the left, like this one here. So that's the tricky one. So whatever way you have to think about it as the opposite of h, or put it in terms of a double positive, whatever you have to do there to help you with that one. Okay? The next type of translation is called a dilation. So what's a dilation do? It makes the graph either narrower or wider than the parent graph. And remember, the parent graph is y equals x squared as your parent graph, okay? So this is either going to make it wider or squeeze it and be narrower. So in this case, we're dealing with the form f of x equals ax squared. All right, so in this case, we're going to deal with an a value. We're talking about the absolute value of a, absolute value, meaning distance from 0. So it's always going to be positive here. If a is greater than 1, so 2, 3, 4, all the way to infinity, it's going to stretch it vertically. It's going to stretch it vertically. And what does that mean? It stretches vertically means up and down, so it's actually going to get narrower or more narrow because it's going to kind of stretch it up and down. It's going to kind of force them closer together each side of the parabola. Where then if a is between 0 and 1, because remember it can't be negative because it's an absolute value, so if it's between 0 and 1, like a decimal or a fraction, then it's going to compress it vertically. Compress it vertically. And so these are the math terms we use, stretches and compress vertically. So if you compressed something, and you pushed it in, if you compressed it vertically, you pushed it from the top and the bottom, it would kind of squeeze it out and make it wider. So if your a value is between 0 and 1, then it's going to make it wider. So your examples over here would be, we've got our y equals x squared here as the blue one in the middle. So this red one here, that one has an a value that is greater than 1, so it stretched it vertically, made it more narrow. And then the green one out here is the one where your a value was between 0 and 1. Maybe it was 1/2 or 1/4. And this one would make it wider, okay, fraction or decimal. So that's kind of what happens with the dilation. And the last one here is a reflection. What happens with a reflection? Reflection is going to move a figure across a line, a mirror image, a reflection, okay? And so in this case, we're just kind of looking at your positive or negative x, or positive or negative a value. So you've got f of x equals x squared or negative x squared. So it's really the sign of your a value, okay? So in this case, if a is positive, then it's going to open upward. And then we know, again, if a is negative, then it's going to open down. Okay, so again, we've got our examples here. F of x, if we do this here, it's going to be a positive a value, where here you'd have a negative a value that would make it that way. Okay? Open it up and down based on your a value. Okay, so let's do a practice problem or two and then see what we got. So this one just says, describe how the graph of each function is related to the graph of f x equals x squared. So remember, that is our parent graph. Remember, y equals x squared is our parent function. That's the most basic. That's the most basic of the parabolas. So how does this, how does this relate to it? So the first thing we've got to just kind of look and say, well, what's our a value? So looking at the a value is a -2. So I know it's negative, so I know right away it's going to open down. So it opens down. What else happens? Because it is, your a value is a greater than 1 absolute value-wise, absolute value is greater than 1, that means it's going to stretch vertically. Or become more narrow. Than the parent function, because everything you're doing is you're comparing to the parent function. And then because of this here, this -3, that's a k value is going to shift it down 3 units. Okay? So we shift down 3 units. So that's just simply comparing what we've got to y equals x squared and what happens with each. All right? The next one we're going to look at is, let's look at number 4. Okay? h of x. And don't worry about g of x, h of x, f of x here. These are just different ways of saying y, right? If they already used, like here they used f of x for y, so they just used g of x and h of x. It doesn't matter. It's just another word to use for y. So let's look at number 4. What happens compared to y equals x squared? So in this case, this is different because this is in the parentheses. So we've got a like x minus h type deal. So h is equal to positive 4, right? Because it's minus 4. So your h value is going to be equal to positive 4. Let me just rewrite that. I don't like that. Okay? So the h value is 4. So what else has happened now? We look and say, okay, well, because it's negative, we've got a negative a value, so I know it's going to open down. So it opens down. But what else happens here? Which, again, I guess means that it's a reflection, reflected, right? We didn't put that on the last one. Reflected over the x-axis. That's basically what it means when you're opening down. And then what else happened here? Well, we're going to, because it's an h value, we're shifting, and your h value is a positive 4. It's going to shift to the right 4 units. Okay? So we're analyzing the graph just based on how that looks. Okay, so you can play around with some of these. This is a multiple choice question, which is good for test, which graph is shown there. And then we get to our lesson summary here and our practice problem. So our lesson summary says, what is the one way the graph of g of x equals 2x squared is different from the parent graph? Remember the parent graph here is f of x equals x squared. So there's only one way it's different. What is it? Based on your notes there. And then your practice problem here says, identify the horizontal and vertical translations and sign of the a value here. So you've got 3 different problems. Horizontal, what happened here? Where did it shift? Did it shift vertical? And then what is your a value based on what we see here as well? Or they just want the sign of the a value. Okay? All right, that is it, folks. So hopefully we do well here and bring questions and be ready to roll.